Okay, so, oh, forgot to mention, when the second derivative is equal to 0, so when the concavity changes signs, it's important that it changes signs. It can't just equal 0. It has to go from negative to positive or positive to negative. And you know this just by plugging in values based on the zeros. If it's a point of inflection, f double prime of x must change sign. That is the condition for a point of inflection, which is what it's asking us here. And it has to be differentiable, which means it's also continuous. And we know that that statement is true. But it could change sign and not necessarily be 0. So we look at a graph that looks like this. This would be an absolute value or piecewise function. Right here, the second derivative changes signs, but the second derivative is not 0 at that point. It's undefined. So that would be an example where it would have to change sign, where it would change sign and still be a point of inflection. We don't necessarily know that it has an extreme value there, because if we look at our example from before, there was a point of inflection around here at x equals 1, but the extreme value wasn't until down here. So the derivative, when the derivative equals 0, the first derivative, then that's a critical point. But a point of inflection is when the second derivative changes sign. So we can cross out 1 and 3 because 1 doesn't have to be true. It could be true, it doesn't have to be true. So based on this, we can determine that it's 2 only.